Saxon Algebra 1/2, lesson 114. We're going to talk about probability a little bit more. Excuse me, my neighbor's mowing his lawn. It's a little bit loud, but I'm outside and I don't want to go in, so, you know, we'll tough it out, right? I wrote this down for the last lesson. Just a reminder that when you're measuring something in inches, if your answer doesn't come out to be a completely even inch, then we use fractions to discuss the difference. We can talk about it in terms of halves, quarters, eighths, or sixteenths. In centimeters, when we don't come out to a whole number, we use decimals. So like if it was 4.7. All right, so that's just something to think about. The difference in the two measuring systems usually gives you a different shaped answer. Okay, but I don't want to talk about that anymore. Let's go on to probability. We talked about the fact that, for example, the probability of throwing heads is equal to the desirable outcomes over the total outcomes. Total possible outcomes. But that's just one throw. What if you wanted to know, sorry, I want to make this correct. What if we wanted to know the probability of rolling heads and then tails? What we do is we multiply. Okay? First we write what's the probability of heads? Well, that's 1 out of 2. What's the probability of getting heads for the second event? That's 2. What about the probability of getting tails? Oh, well, guess what? That's also 1 out of 2. So, the probability of getting those 3 in a row equals 1 in 8. Does that make sense? The most interesting way, I think, to look at this is, let's see, your family is girl, boy. Now I'm drawing a blank. Then another girl, right? Do you have a younger sister? And then a boy. I know your youngest is a brother. I think that's right. So what's the probability, if you have 4 kids, what's the probability of getting that exact pattern? Well, the probability of getting a girl is 1 out of 2, right? You're either going to have a girl or a boy. Those are the only 2 outcomes. Girl is the one we're measuring. Then here comes you. Then here comes, I think that's a sister. So the probability of anyone who has 4 kids of getting this exact configuration is 1 out of 16. There's 16 different configurations of gender you can have with 4 kids. My family of origin is a different pattern. And then the family that I'm the mom of is this. So between your family and the 2 families that I'm part of, we cover only 3 of the 16 different variations for 4-kid families. So when we want to find the probability of what we call independent events, we multiply. Right? We consider each toss of the coin to be an independent event. That has no bearing, right? Just because I threw heads the first time doesn't mean I'm going to throw heads the second time. I could, but it doesn't affect that, right? They're independent. Just like the gender of each kid is independent, right? The fact that you have an older sister didn't make it more or less likely that you would be a boy. It's an independent event. So we find the probability of each event separately, and then we multiply them all together. And I didn't do the actual problem. Let me just do it really fast. The example. I made up my own that was similar. Example 114.1. A fair coin, meaning it's not weighted to make it land more likely on heads or tails, is tossed 3 times. What's the probability that it will come up heads every time? Okay, so we write down the scenario we're looking for. And then we find the probability of each event. Heads is 1 out of 2, 1 out of 2, 1 out of 2. And then we multiply those together to find that we have a 1 out of 8 chance of rolling heads 3 times in a row. That is lesson 114. These 2 lessons were super easy, Caleb. I hope you enjoy the mental break. Thanks, bye.